and Rashad. And then against them, the team that choose against the water reuse is Muhammad, Ahmed Mekki, and Ahmed. Welcome both teams, and let's start with the water reuse.
Good morning, everyone. Today we are going to support water reuse by defining it and by defining it well for you, and by mentioning some applications. And with the applications we're going to talk about the benefits and examples of the applications. This presentation will be given to you by Zef Dabab, Hamad Abbas, and myself, Rashad Daraj. First of all, what's water reuse? I'm not going to start my presentation by a typical way, like what's the importance of water and how to use it in our daily lives, because we already know about this. I just want to say, like, whether we know it or not, or whether we like it or not, most of the things that we use in our daily lives are reused or recycled, including the paper product, metal product, and leather product, and etc. So with the availability of science and technology nowadays, we can also reuse water. In order for us to appreciate the water that's reused, we have to understand where it's coming from. Now, in the common water systems, we take the water from the groundwater or surface water, we treat it in special plants so that it reaches a certain level of quality. Then we use it, we distribute it for people and we use it. After that, we have always to treat it before getting it back to the oceans or to the land, which is disposal. So here at this point, it's up to us to decide whether we want to reuse this water, which is already treated and already we spent much cost on it, or just throw it back to the ocean. Let me talk about the drivers for us to reuse water. The most important thing nowadays is the increasing demand for water. Since the Second World War, the demand for water has been increasing by 100%. 100% increase in water demand since the Second World War. And also at 25% is expected by 2030. This is not surprising if we know that 6.6 billion is the population of the world today, and is expected to reach 8 in 2030. So, also we know that the rate of water is increasing by more than double of the rate of the population growth. So population is growing and the demand of water is also growing, but with more than the double of that rate. Along with this reason, there is also the lack of water. The demand is increasing and also the lack of water is increasing as well. We all know that 70% of the earth is water. So how are we lack of water? We have this lack of water because 97.5% of this water is saline, so it's salty. And the remaining 2.5, only half of it is fresh for us to use directly. The other 1.25% is in the ice form. So this creates for us the lack of the availability of water. Another driver for us to reuse water is to benefit the environment. Of course, we benefit the environment by reusing water, because when we reuse water, we have an additional source of water. This additional source of water will reduce our dependence on the natural ecosystems, so that we don't have to take much water from the ecosystems, and this will save, of course, a lot of wild animals, fish and birds, etc., by creating the adequate water flow for them. Also, when we reuse water, I told you about the story before, like when we dump back the water to the ocean or to the land. When we reuse water, we are reducing this disposal to the environment. So we are reducing the pollution, basically, that goes to the environment by disposing the water. Also, it's worth mentioning that there's some recreational reuse, like creating lakes and stuff, which is also enhancing the environment for us. Another driver is the economic value of the water used. The water used has an economic value, and this value depends on where we are using it. The applications that my colleagues are going to discuss will show you how the economic value of this water is going to be determined. And finally, in all, when we reuse water, of course, we are going to reach a sustainable development. Why? Because the development itself will reuse the water by itself, which is going to be more sustainable for us. It's better than getting water from different sources, disposing it at the same story. It's better to have a small kind of cycle. And now I leave you with Saif Abdelbak for talking about the application of water use.
Okay, my name is Saif, and now we'll start with talking about the applications of water reuse. So now let's start with the first application, which is the industrial water reuse. Of course, most of us know that the industrial facilities consume a lot of water. So to overcome such problem of water consumption and the scarcity of water, many industrial plants have decided to reuse the wastewater. Basically what they do is that they take the wastewater and treat it to make a water of good quality. And what they do is that most of the time they have their own technical plant next to the industrial facility. So they take the water and disinfect it and make a water of good quality. So let me give you an idea about the numbers here. As you can see here, this water plant in Fort Collins, it has used about 245 million gallons per day of recycled water since the 1980s. So that's a lot of water. And here it's another example of a power station plant at Australia. They have used 1.2 million meter cube of water, of treated wastewater per year in 1994. The second application of water reuse is that we use it for concrete mixing. We know that for concrete mixing, most of the time we are using the potable water to achieve good properties of concrete. But many research have been made due to a lot of consumption of water in concrete mixing. As you can see here, to make a concrete, normal weight concrete, we have been using 800 billion liters of water during the year 1997. So that's a lot of water. So what they have done is that they are taking the wastewater, treat it, and use it for concrete mixing. And many studies have showed that the concrete mixed with the treated water, surprisingly, it has achieved higher compressive strength than the normal concrete mixed with the treated water. So that's something to consider. Okay, now we can use the water for toilet flushing. Of course, the water used for toilet flushing is the grey water. The grey water is the water that's coming from the domestic practices, such as washing hands, showering, as you can see here. It's the water coming from such domestic practices. The problem with this water is that because it comes from different sources, it has different chemical components. So we have to consider knowing all the components present in the water to avoid any health-related issues. And to have an idea about the numbers of savings is that if you use the treated grey water for toilet flushing, it saves between 29 and 35% of the consumed water. And now my colleague Abbas will continue with the application.
Good morning. Another benefit of wastewater treated is agricultural irrigation. As we know that the demand of fresh water is increasing as the population is increasing. And as the population is increasing, and sometimes the demand can exceed the supply of the fresh water. So recycled water can be used as a conservative source for the irrigation. And recycling water can reduce the pressure on the surface water resources and the depletion of groundwater. Now this picture shows a huge reduction in freshwater consumption in Australia over a period of 7 years, starting from 2005 and 2011. In 2005, the freshwater consumption was like 37 million cubic meter, and in 2011 it was reduced to 29.79 million cubic meter. It's approximately like 22% reduction in the total freshwater consumption. Also, treated wastewater is used in agricultural irrigation because of its economic value. Recycled water has a lot of amounts of minerals like phosphorus and nitrogen, and these minerals can be used as fertilizers for the crops and plants. And because of this, recycled water is a better water for irrigation than tap water, since it has a lower amount of chlorine that is used, and that might be harmful for the crops and plants. Also reducing the energy requirement and cost. Like usually extracting water and transporting it requires a lot of cost and energy. For example, using river water require a lot of transportation costs to supply it to the farm or irrigation field, because we are transporting it from farm location to the field. Also, pumping groundwater up will require a lot of energy and resources. Compared with that, recycled water has the least amount of cost and transportation cost and energy, because it's the water that we already have and we are just recycling it and using it again in the same location. This diagram shows the energy required, the amount of energy required to provide different kinds of water to the irrigation field. For example, desalinated flushing water would require 4,400 kilowatts per hour of energy, while recycled water requires just 400 kilowatts per hour of energy. It's a huge difference between them, which means that we are saving a lot of energy. The last application of reused water is groundwater recharge. Recycled water is used to effectively to replenish and recharge groundwater basins and aquifers in two methods. The first method is using surface spreading, and the second method is using injection water through wells and barriers. And because of the uncertainty of the future availability of water resources and the lack of water during drought seasons, recycled water is considered as a vital source for groundwater recharge. Finally, we conclude that recycling water is a good step ahead in creating a sustainable environment and meeting the increasing demand of water. That's it. Any questions?
Thank you.
Thank you, everyone.
Pleasure. You did great. Now we'll move on with the team against water reuse with Ahmed, Maki, Ahmed, and please welcome the food.
Hello everybody, we're going to present not in favor for water reuse, and these are my group members, Ahmed Meki and Mohammed Morgan. Basically, as you saw, the other group, they talked about the advantages and benefits for using water reuse, but in fact they did not talk about the risks, which we are going to do. If you can see the first picture here is the challenge of water reuse, and they did not talk about all these, which we are going to talk about. Basically, the operation, acceptance, water resource management, the regulations, norms and standardizations and the treatment is the most important part of optimizing water reuse. All these procedures have to be taken care of, especially the standardizations and the regulations which government have to apply to the reuse. And then we have the financial and economic feasibility and the hygiene and health. These are the two most important factors apart from the process of creating water reuse, is because they have to be the hygiene and health, because governments cannot ensure that the effluent is 100% clean for reuse, for agriculture or irrigation or even for drinking. And then the financial and economic feasibility. It's very expensive to create a treatment plant for water reuse, this is not taking into consideration the piping and distribution system, which you guys did not mention. If you're going to reuse water, you need to be able to redistribute it. So yeah. And if you move on to the next slide, this is the passenger which Ahmed is going to talk about.
Good afternoon, everyone. One of the most important aspects of water reuse is the health risks associated with water reuse. And my colleagues here failed to mention anything about the health risks associated with water reuse, so I'm going to talk about them now. And the main concern is the existence of pathogens and waterborne agents in reused water, such as bacteria, viruses, and helminth, and of course organic chemical compounds. And this table here shows the percentage reduction, the maximum minimum log reduction in different types of bacteria and helminth according to the different treatment processes. So you have secondary treatment, ponds, chlorination, O3, UV, which are considered to be tertiary treatment processes. So as you can see, there's different percentages of reduction And what we can extract from this table is that pathogens can still be detected in tertiary treated recycled water. As you can see, for example, UV removes 4 to 6% of phage, and also you can see here that also there are low numbers such as chlorination, which removes only 0.1 of C carbon. So what you can extract also is that some pathogens are almost unaffected by disinfection processes, and this is very important if you're talking about reuse of water, and you still have some pathogens or waterborne agents. It's very risky to use that water. And now I'm going to talk about the quality and the problems associated with water reuse. Of course, the main two concerns are the endangered public health and the environmental deterioration associated with water reuse. And these are caused. They're caused because of polluted water and soil recipients, health hazards for farmers by the uncontrolled use of reuse of treated water, and also the endangered construction of the endangered consumption of crops irrigated by reused effluents. A lot of reused water is used for agricultural purposes and in irrigation, but in fact there are no standards to ensure that the water used is eligible for irrigation and agricultural purposes. And as we all know, that's a risk not only to the environment but also to the people who, like for example, consume the crops that are watered by reused water or treated water. And if the treated water doesn't have the proper quality, then that's a major health risk. And also, this tree shows the different problems associated with the storage of water that's safe for reuse in agriculture, which is for example, we have unsustainable wastewater treatment and production of low quality water able to be reused. And in fact, most of the water that is a lot of studies show that most of the water that is reused and treated to be used for agriculture is of very low quality. And also the unsafe and unsustainable reuse of effluent in agriculture, lack of awareness on the reuse of treated wastewater in agriculture, and many more problems. And now my friend Mohammed my colleague Mohammed will talk about the costs associated with reuse of water.
Hello everyone. For sure they didn't go deep in the cost of the treatment because it's too much to construct a treatment plant and to construct a distribution system. First of all, to construct a piping system from the properties to the distribution to the treatment plant that till now we didn't construct it. They have to separate the gray water from black water. So this will cost them the piping for the gray water and the black water. Moreover, they will have to construct the treatment plant, which is, this graph shows that it costs $2.2 billion. 37.2 is the operation and maintenance, which is annually, okay? And the equipment costs 17.5%. The design and engineering services 14.2, and the wastewater treatment equipment is 24.5. Okay, this graph shows the cost per cubic meter for desalination and water recycling. Because here in UAE, the most used one are the desalinated water and the recycled water. If we are already desalinating the water, and it costs us $2.27 per cubic meter. We add over it $2.1 for recycling it, which is too much. Also, this of course without the piping system of the network. If we add the piping system, that will cost us triple or maybe 10 times the cost of this one. We didn't add also for the cost that the government will have to pass the bills of the bill of water and will have to give a more enhanced and advanced water, what we call it, the regulations must be very enhanced so the people will believe in them and drink treated water and use it. Here it shows that the piping system was not mentioned in the cost graphs. Okay. When we were doing our project, we have done a survey here in AUS in the library among 18 students. We asked them, would you drink wastewater that has been treated? 13 of them answered no, and 5 of them answered yes. The people who answered yes, their reasons were that there are people that have no water to drink like in Africa, but also these people doesn't have the money to construct the treatment plant. So in some African countries or undeveloped countries, they drink untreated water because they don't have the cost to build a treatment plant. Okay. Here, my favorite part is the human perception, which is the answers of the students, that if the government want to convince the people to drink wastewater, they have to put the regulations that they maintain and give a clean wastewater for them. Now I'll leave the floor for Ahmed.
So we cannot say to basically not reuse water because it's been implemented nowadays and it's been one of the most feasible advantages of treatment. But we came up with an alternative to reuse, which is reduce. As you can see, we can reduce the amount of water we use, as most of the water pollution that comes is from abusing the water. If you can look at this graph, this is a hierarchy chart that shows us that the first thing we have to do is reuse and then recycle. This is the high risk at least preferable is recycle and the reuse and reduce. And if you just have a read of that, you can see that reduce is that you can avoid water consumption or reduce using water conservation measures. Reuse is reuse water within a single process or use harvested water for another purpose without treatment. And recycle says use harvested water for another purpose after treatment. So basically, we're thinking of an alternative to is to reduce water consumption rather than reuse it. And moving on, this is another hierarchy chart, and this is about sustainability, which these guys mentioned. And if you see the sustainability chart, the most sustainability is to reduce, and then reuse, recycle, and dispose. And we came up with this phrase that says refuse to reuse and recommend to reduce. And with that, we conclude our presentation. If you guys have any questions, we have time.
Especially on the part which talks about the cost and pathogens and also the higher risks, this one they showed here. So what do you have to respond on that? Please one of you and please not get too close. So say, what would you like to say? Would you like to start or shall?
So what's your first problem? Tell me, discuss it. What's your first problem?
Okay, so can you repeat?
Let's start with something at least. What's your first?
What are you?
The first problem, the main concern is the health risk associated with water we use.
Yeah.
And you didn't mention anything about the quality of the wastewater after treatment.
We want to talk about technical stuff. We will talk. We didn't talk.
No, but this is a very technical topic.
He's so now. Do you want to respond on the point that you didn't take into consideration the pathogens, disease-causing
Okay,
bacteria?
can you give me an example of a case where someone got a disease or something from a developed country who followed the regulations of water reusing? Can you give me an
Yeah,
example?
there are many cases. In our countries, for example, in the Middle East, in the Mediterranean region, there are many cases of people getting sickness and diseases associated with using, consuming crops. And as you know, like for example, like in Africa, it's a huge It's a huge crop land.
I said a developed country who's following the regulations.
Yeah, but I mean,
Specified regulations. We have regulations here. You start talking about the pathogens and stuff. You can't reuse water without following a specific.
For the type of reuse, there's
That's what we're saying. That's what we're saying. You didn't mention anything about the criteria that's associated with
I
water.
was waiting for you to say that, so we can respond.
Okay, so they tricked you basically. So, okay, anyways, your second point. What do you have second point against them? You mentioned maybe the costs. What do you have to say?
No, also the health risk. Like,
Okay,
he said that basically recycling water is like recycling other things like paper and stuff. We don't consume we don't eat paper. So how can you
And
associate?
you don't have to
how can you associate reuse water
We're
with
not saying about
recycling?
drinking water.
Yeah,
We're saying about contact. You are
Yeah,
contact
but
with
it's
the
still,
plastic.
the water's contact with the crops, with the birds use, different parts of the ecosystem. But humans,
Okay, guys, I appreciate your work, your research. You said a lot of things about drinking water, right? You focused a lot about drinking water, and you did a survey among 18 students about drinking.
No, not exactly drinking, just water
You
use
said
in
drinking.
general.
You said
It's not
drinking.
drinking, this is only for drinking, we have like,
Okay.
we have a sample.
the survey was about whether or not you would drink water.
Okay, but
That's about human perception.
But you both refuse using used water or reuse or treated or whatever for toilet flushing. What's your contact with toilet flushing? Do you know how much percent you consume per toilet flushing? Why do you need to use your drinking water for toilet flushing?
What is the cost of separating the pipes of, when you send them to the water treatment, okay, the gray water and black water, okay, this an issue, and constructing a treatment plant for gray water and black water is an issue. Redistributing the water from the treatment plant to the property is an issue. So you are costing three things together. So this is an issue to retreat and reuse the water.
Can I add one more thing? And you're talking about, you're saying you reusing like water and flushing, for example, I think what you mean is like if you make a small wastewater treatment plant, and for example in a mall, so you can use the flush water again and redistribute it. That's what you mean, right?
This is an example.
Okay, but why reuse when we can reduce? Like if you like why don't you like raise awareness about reducing water and reducing the amount of times that people flush and enhancing the technology to basically to allow more reduction of water consumption, like dual flush systems, these kind of things. Invest in that. Why let the people know that you can, you have this much water to use, so you can just use it when you can reuse.
Why don't we apply both of them? Why don't we reduce and reuse at the same time?
Yeah, but
What's the
that's
problem with
the
that?
cost associated with
Yeah,
that.
of course. Any distribution system would get. You mentioned about the cost of piping and stuff, but any distribution system needs pipes and needs maintenance and needs work every time. It's not an issue at all. What you're raising is an issue, it's not an issue. And you said it yourself, but you didn't point this out when you were talking about the costs. You said desalination costs up to 2.2 or 2.3%, 2.3 I don't know, million dollars or whatever. While reuse by itself costs 2.1. So what does that mean?
Okay.
You are saying if we take after desalination, right? We take the water and reuse it again, we're gonna end up with five for example, 5 units of cost, right? But when we reuse, we are taking water that is supposed to be for disposal, right? We're not taking it. We're not starting from zero. So you don't have to consider the two that already passed. These are already done.
You know something called cost to benefit ratio? You just said that the cost of putting a pipe, the cost of, you didn't compare it to the benefit. If you compare it to the benefit, you find the ratio is way more than one. You just said the distributing pipe for, I go and find pipes for $5 or something, and then leave them here. You didn't think about the savings in the future, because if you think about the savings, the cost to benefit ratio will be way more than one.
Okay, just one more thing. If you want to construct a treatment plant, you are paying just one time for the construction. But imagine if you want to bring fresh water from river or whatever, how much does it cost you for transportation and distribution? It's like every time you are paying money. But for the treatment, it's one cost. That's it. You are constructing treatment plant and you are recycling that with the water that you have. That's it.
You're done? Okay, what do you have in response?
What was your point again? About the cost?
He mentioned that.
Okay. You said desalination costs 2.3.
Okay. About the desalination. UAE let's talk about UAE now because we live here. It's already using the desalination plant. So it will just ban the desalination plant and start using the reused water, okay? And the amount of water that they are using in UAE is too much higher than the amount of reused water that they will recycle, okay? So the amount will be added, the recycled water and desalinated water.
I don't get your point.
Okay, I'll repeat it. We already desalinated water,
Okay.
okay? You want to reuse the water, right?
Right.
Okay, the water that you will reuse will need what? Will need the cost. Okay, the cost will be added. The desalinating, the cost of desalinating and the cost of the recycling. To construct a treatment plant, okay, with that and banning the desalinating plant will cost initial cost, okay, and distribution cost, which is the movement of water from one point to another. So you are going in the same circle. If you want to reuse the water, you have to distribute it, and to get it from a point to the property that you are distributing to it, and to get the water from the property to the recycling plant, it's the same. So you are moving in the same circle.
Yeah, I get your point, but there's something you have to understand. When you desalinate the water, you don't have to go back and desalinate other water, you know? Like, we are done with the desalination, right? You get this amount of water. This amount can be reused 10 times, 20 times. There's no limit. Nobody said anything. Because practically you can reuse as much as you can, as long as the technology is applied and you are meeting the standards which you have here. That's it. What you have always to add the cost of desalination.
Okay, do you ensure for the community that you are sending the water to them that the water is clean? Does it reach their home?
Of course, what water guarantees now that what you are getting is?
That there are regulations in it now.
Yeah.
If the government want to do a new regulations for treating water, this will be costly because high technologies must be used.
What are technologies? We know what technologies.
No, really high technologies must be used to.
You mean like tertiary treatment and...
Yeah, tertiary treatment and secondary disinfection for that. Okay, and
desalination is not really enough.
No, we're talking about the UAE in this case.
Okay. Do you guys have any other points you'd like
No,
to
it's-
add?
yeah.
Just they will add on the...
And you want to keep desalinating water, keep taking the water from the sea and keep dumping water, high salinity water into the sea. That's what you want. You don't want to reach the water.
Your point.
Just wait, please.
No,
Taking this
I'm
one.
taking
Please.
the water, the wastewater, treat it and reuse it. I don't want to keep taking he said that instead of reusing the water, keep taking water from the sea, desalinating it, keep taking water.
That's what's
No,
happening.
no, no, that's what's happening.
Yeah.
Our
Which
point
is
is to reduce.
We want to reduce the consumption. This is the solution.
Yeah, that's what we're proposing. You're proposing reusing the water. You know, we
Yeah, I'm against that. I'm against keep taking the water from the sea.
But against
Okay,
disposal.
let them state their point, and each will have a turn. Do you guys have anything
Yeah,
to like?
I was a student for civil engineering, so you probably took the environmental engineering course, and the first thing you learn is sustainability. And like there's there's three pillars of sustainability: economic, social, and environmental. Okay, so we're telling you that basically the pathogens are still in the water, the reused water. So that environmentally that's risky. Okay, and then the economic value. So it costs a lot to reuse water. Okay, and then the social aspect, which is related to the human perception. Like people are not really comfortable with reused water. And after that, it comes like we all know the sustainability hierarchy, and reduce comes first. So basically, I think that we have to invest time and money in reducing water consumption before we resort to water reuse. We're not saying it's a bad choice or we shouldn't reuse water, but you should first we should reduce water, and then consider reusing it.
Okay, anything to add here?
I was basically going to say the same thing.
Nothing to emphasize on because it's gonna be somehow you're gonna answer and then later on you're gonna have your last point to discuss. So please.
So basically, they're each circulating on the same point. I told them, don't talk about the cost. They are talking about only the initial cost. They are not talking about the benefit. They are not comparing the benefit with the cost. They are just training the cost. And we showed you examples of how much savings we have saved. And the amount of water being saved is a lot of water. And he's saying about pathogens. and you're talking about the pathogens. And if I treat water now for you and show you the result of what is in the water, it will be the same as the water that you drink.
By the way,
And you will not be satisfied to reuse it, not to drink it, to reuse it in other applications.
by the way, all the numbers that you showed, that the pathogens that remain in the water after disinfection and all this stuff, all of them fall in the range that's acceptable for other uses than drinking. Like if you see the tables here, we have for recreational water use, we have for the toilet flushing, we have for the what's it called? Industrial water use. Okay, for irrigation, all these range, like for each reuse there is a range. Okay, and all the numbers that you say fall in the range, so it's acceptable. You know, for irrigation, for all these stuff, even if there's pathogens, they are acceptable in small ranges. Okay, so it's not a big issue.
Thank you, both teams. Both did great. Both of you mainly talked about the cost, environmental impact, and public acceptance. I would give the chance for both teams to conclude because we don't have more time. So I'll give you like 2 minutes to discuss the final thing you guys would like to say on both of you, like for both teams. So please have 2 minutes to discuss between each other what would you like to say as a concluding statement. For the audience, please prepare some questions related to this topic and whether you like it or not. You guys are done?
Like us.
Okay, who would like to give their final statement first? I don't know.
No, we start the presentation. We start.
Okay, you guys please start. It's
Okay, they were attacking me and us as a team about the cost, but we mentioned the cost as a point of the whole issue. Our point is to reduce, not to reuse. So we proposing reducing instead of reusing.
And like say you mentioned about you talked about the cost benefit. So basically what I want to say is that before looking into the cost benefit aspect of reusing water, look at the cost benefit aspect of reducing water, which I'm sure is a lot better than the cost benefit aspect of reusing water. So you have to look into that first and compare it to the cost benefit of reusing water.
okay, but we're not. I would like just to remind you guys that we're not here giving points to the other team. We're concluding for the audience to take a stand with or against.
Okay, so this my last point is not only for you guys but for audience as well. We're stuck in a 3-phase stage. The first stage is the drawbacks, is what we're talking about. The third stage is the benefits, what you guys talked about. The second stage is actually convincing people, right? Convincing governments that water use is good. And this is the most important factor. As you saw our survey, people didn't agree to reuse water. I mean, if you tell people right now, even governments, you think governments are going to invest 2.2 billion on the flag? I doubt it. Even investors. You need to hit them with the right points and also show them the drawbacks. That's the most important part. Benefits come afterwards.
Thank you. Yes.
Okay, we would just like to say that we're still supportive for what we say. We're supportive for water reuse because I respect all what you say, but all what you say are not issues because we always found response for what you say. And we have to understand that water reuse is becoming a science now, a technology. It's not anymore an opinion or just a trial or something. We're not trying. This is science and we are applying science. Okay? Regarding the cost and the benefits, I think in the long run, if you calculate it in the long run, of course we are going to win in this. Okay? Maybe there are initial costs, there are many things, but the benefits are much more than the cost. And there's
Any
nothing more.
additional words? Okay. Thank you, both teams. Please cheer for them. No fighting because Ahmed, okay, I have, now I would like to give the audience a chance to ask, no, you guys, where are you going? it's not done. You fought against each
Ask all the
other.
guys, ask.
Okay, I have a question.
Yes.
You say that the distribution system it will cost more and these stuff. If you're using the water in the building, so we have the wastewater treatment plant, okay, and when the water is dumped, the waste, it can be reused within the building. So there's no cost rather than transporting it to the receiving bodies, which would be more costly.
The cost of the treatment plant in the same building.
Okay,
They need to fix
but I mean
pipelines.
the pipes.
Yeah,
Rather than
but it's
transporting
the
them
same.
to the sea or to the surface water, we're using it within the building. So there's no piping, no.
There has to be different piping for
Yeah,
the
but
water that you receive and the water that you supply back, right?
And depends on what water they want to reuse. They want to use the gray water, black water. So
Separate.
according to that, you need to separate the water.
Okay,
And
another
it
thing.
depends on the type of building as well, right? I mean, if it's a residential building and you have like around, let's say 200 flats or apartments, 200 apartment means like, let's say, roughly 500 people, I guess. I don't know how that works, but yeah, you get my point. There's a lot of people needing to supply water.
Okay, do you have any other point to
Yeah.
add that? Yes.
You said reducing water and reusing. How will you reduce it?
There's a lot of ways to reduce water.
And you
Raise
mentioned
awareness.
let the people reduce the amount they flush the toilet. Can you do it?
Yes,
Is it possible?
No, I mean, like sometimes I mean, people do flush for sometimes they flush twice, it's the same. It's not just, flushing
Yeah,
the
I
toilet.
know.
And it's raising awareness about reducing water consumption. You do use a lot of water when you flush. So basically, if you can somehow control that, that would be better.
Would you like to
In the US, we just see pipes running, water just flowing everywhere. The agriculture and even like,
So basically, what you want to add that we can use different technologies like that. They would
Maybe not
system
implemented the water use, but it will be for sure because it's very beneficial.
Okay, thank you, Namis. I think, okay, now I think we have a question.
I want to ask the second group, how you will convince people to reuse the water? What is the strategies or what you will say to people to reuse the water? Not only drinking, but other like showering, cleaning cars, anything. But especially in drinking case, how you will how will you convince the people to drink the reused water?
Make them take the Tarkazis class. No, start lecturing them, giving them presentations like the one we just presented. Giving them more.
Not every people are knowing what is bacteria, what is.
Yeah,
Are not all civil engineer or
Maybe in this part
chemical
of the world
engineers.
only. Maybe in this part of the world, but like outside it's applied. And we're not talking about drinking. Okay, we are with you in drinking. Okay, there's a social perspective that we have to take care of.
Yeah, and I agree with you that we can reuse it with the cooling system, with cleaning streets. Yeah, we can use it in other purposes. But in the drinking one, how you will confuse?
Drinking, we're not into this. It's not the scope of our research. We're not because we know drinking is something different. We're just talking about the non-potable reuse. Okay?
But what about water reuse?
What about
So
People is disadvantaged. They drink the used water.
Okay.
There's no problem about it.
Okay.
You can make advertising, you can aware the people about
So
about
basically,
bacteria
you're
and how it
asking
can
to
be treated.
make awareness campaigns. This is
They can aware them to reduce water instead of reusing.
I'd just like to make one more point.
We're
There are
still
government regulations for
we're
a
not
certain
against
amount
everything.
government regulations for a certain amount of bacteria, right? But would you honestly drink if you know that there's little amount of bacteria in it?
I mean, and how do you know that they actually they follow these procedures? That they go through?
Again, other thing, how would you guarantee that this one is clean, the normal drinking water also?
Yeah.
Yeah, and that's what it's saying.
Okay, so
Or the food, the fast food you eat, do you guarantee it's clean?
who else has this?
Fast food is
Okay,
not
thank you, Namis. Thank you, Namis. Who else have a question?
I want to further this team. Like the survey which you showed us of 18 people, like how many people from those 18 people know that the water reuse, they do not have those pathogens and all this? Like, do they have the knowledge about this? Maybe they have this perception that even after reuse, it's not safe enough for us to drink the water. Maybe they're not engineers like us,
The survey was done on 20 people,
Mhm.
and 11 of them are civil engineers, seniors. So if you tell me they don't know about reuse and they're not fast
Okay.
environmental engineering,
Only 20 people out of this 1,000 people? What about the rest?
it's a sample of the population. It applies.
Okay, thank you, everyone. This was an interesting debate, and I would like to conclude and say both we need to reduce and reuse in order to sustain our environment, in order to keep our water from becoming scarce, at least in the regions where they have water. So thank you, and